Hi, this is question number 1 taken from October 2002 Advanced Level Maths HSC S2. The time taken, 2 minutes, for a special untyped rest paint to dry was measured for a random sample of 120 painted pieces of metal. The sample mean was 51.2 minutes and the unbiased estimate of the population variance was 37.4 minutes to the square. We need to determine a 99% confidence interval for the mean drying time. Okay, so the information we have is here: the sample size, the sample mean, the unbiased population variance, estimate of the population variance, and also we need to find the 99% confidence interval. Now for this type of question, we need to find the upper limit and the lower limit by using the formula confidence interval is equal to the mean plus the z value times the the standard deviation over the square root of n. Right, and for a 99% confidence interval, we're looking at the distribution curve, and this is going to be here 99%. Now it's a two-tailed situation here, so what are these two? It's going to be 1 minus 99% divided by 2, so we have 1 minus 99% divided by 2, and the area to the left and the area to the right is going to be 0.005, so that's going to be 0.005, 0.005. If we have to find the z value here, and this is the negative one, how are we going to do this? So that's going to be, I'm sure you're very familiar with that from statistics 1. So 1 minus the xi of z is going to give you this area, 0.005. Therefore z is going to be the inverse of 1 minus 0.005, which is 0.995, and you need to look in your table to find the value of this, and this is going to be quite easy. If you check that out from your table, you're going to see that here we are, 0.0095. The z value is 2.576, so we have then 2.576. Okay, so we're going to go for the lower limit first for the confidence interval. Lower limit of the confidence interval is going to be the mean, which is of course 51.2 minus, because you're looking for the lower limit, that's plus or minus the z value, which is we just found 2.576 times the standard deviation. The standard deviation is the square root of the variance, so we're going to take the whole square root of 37.4 divided by the sample size, which is 120 here, and just do that in your calculator. So let's call this the lower limit, alright, and so let's plug these value in. So 37.4 divided by 120, and you take the square root of that, it's going to give you this much, and you multiply by the z value, which was 2.576. Okay, and that's going to give you approximately 1.4381 something. So the lower limit then is going to be 51.2 minus this value. So we're going to take 51.2 minus the answer, and that's going to give you 49.761. So 49.761, let us say approximately 49.8, and for the upper limit, that's going to be 51.2 plus this whole calculation here. Alright, so this whole figure, let's just say again we're going to have to do the same thing. Alright, so 37.4 over 120, and take the square root of that. It's going to give you this much, and you times the z value, 2.576, here we are. So you add this time 51.2. It's going to give you the upper limit 52.638. So that's going to give you 52.638. Therefore, the answer is going to be a 99% confidence interval for the mean drying time. For the mean drying time is going to be then the lower limit 49.8 all the way to 52.6. What it means is that I'm 99% confident that the mean drying time, which is 51.2, is between these two values. So here we are, 3 marks.